Well, welcome you to the studio, and this time for the 11th out of 100 air crash investigations that I have checked, and I'm just reviewing them to see is there anything that we can learn from this so that we don't have to get into the same traps in future. Today specifically we're going to have a look at the Agusta Westland 109 that was involved or that crashed onto a ship while it was taking the marine pilot off. So let's just look what the scenario was like. Not the exact same helicopter, neither the same ship, but the same scenario. The helicopter itself came into the hover on the port side of the ship, and in the hover was winching the captain from the from the port bridge wing, and the wind coming from the seaside here as well, but eventually everything wanted the aircraft to drift. It did in fact then drift to the right and struck, and after that this is how the crash happened. But let's have a look here. It's maybe better to say that once you look at the physical aircraft and the evidence that is in front of us, let's consider it a little bit. Everything had to do about the control of the helicopter. Now remember, the first thing that we said is that the wind was coming from the left-hand side, and the cyclic stick, and that's the stick in the center, had then to move to compensate for that. So let's just have a look here on the setup. There's the wind. The helicopter is sitting already here. You can show that I tilted the vertical vector or the thrust, or you can say the lift vector, to compensate for the wind, and then the winch here from where the captain, the marine captain, was winched from. This is the actual bridge of the actual aircraft where this accident happened, and that was the first point of impact. Here on the right hand side, what happened is, as they winched, now whether it hooked up or not on the ship, I don't know, it wasn't established, but whether it hooked up or not, the aircraft then started rolling to the right, and in other words drifting to the right hand side, and actually strike. That's the first point where it struck. Now what I want to do here is just to compare the cyclic positions. Now the cyclic, as I said, is the stick in the center, and every time something that wants to make a drift to the right must be compensated to the left. So let's just very quickly go through this sequence. I say here this is what the cyclic looks like, and I say there's no wind condition, so I have it nicely centralized. All right, this is where we've got the ship, helicopter on the bridge wing, and we are set to go. Now when we introduce the wind, you can see that the cyclic must be offset to the left to compensate for the wing, as the aircraft wants to drift onto the superstructure on the right hand side, which obviously one cannot afford. Now taking into consideration the wind plus the two aircrew, and you can see that's all on the right hand side of the longitudinal axis of the helicopter, meaning that it wants to drift to the right, even more offset to the left. Now there's a limit. There's a limit. You know, the cyclic can't move. There is a definite control limit here, and the idea is just never to reach that limit. In this case, when they were taking the last person on, now you can see all the factors that wanted to make the aircraft drift to the right had to be compensated by the cyclic to the left. Have I over-exaggerated the cyclic positions? Yes, but it still holds true for the argument. And now, did the captain hook up onto something as they wanted to winch him in, and that is the marine captain? Did he, something on his body, hook to something on the wing bridge? That would have meant, if the winching operation then continued, it would just simply have drawn the aircraft over and the pilot would have run out. Irrespective, as you put all the facts together, it could be, with strong enough wind and strong enough weights, that the pilot can run out of lateral limits. All right, so lateral controllability depends on. Now, I've mentioned 3 factors here, and the first one is, I say, the wind. Wind is a huge factor. It doesn't go about whether the helicopter is physically strong enough, but remember that the Cyclic must move off into the wind. Normally the aircraft is strong enough, and maybe the tail rotor has got enough, and with the rudder and the yaw you can keep it, but you still need lateral control. The next one I said is the amount of weight, which was now all on the right hand side here. And then the last one is, what is the control effectiveness? How much lateral control is there? The point is, though, that you're going to run out of lateral control. So helicopter pilots, you must look out for these things. This is not a trap for beginners. It's just a trap. I've been there. But I was lucky. They couldn't jettison the marine pilot. I think that would have been very bad for business. So in this case, well, they didn't do that. I think it was against policy as well. But here you can see the aircraft, as with the impact, it was quite destroyed, the canopy part. Now the marine pilot ended up in the water, and he was recovered, and he recovered from his injuries, went back to work. The pilot himself also got flung out, and he was rescued. He's back into a flying job. Unfortunately, our winch operator, very, very nice young man, but he got stuck inside. He couldn't undo the clip from the belt. Of course, remember, he had to be tethered to the helicopter for doing the winching operation, and he couldn't get that loose. And unfortunately, that was the end of this tragic accident. All right, until next time, please be safe, look after yourself.